Session. Today's topic will be C-style arrays. Yeah, we're going through this topic quick, and I would say let's dive into that. So, introducing to C-style arrays. I hope you will really appreciate also like my English learning course. Just kidding. You know, guys, English is not my native language, so I'm trying to get better, but I know that I'm not really good in it. So, okay. Now that we have covered a std vector and std array, that's actually, this is really interesting because I did also like the vector thing, the array thing, and that even if you have, you know, if you're using learn C++, I think the source is kind of, it is good, right? Not gonna lie. Just my point of view. If you think it's not good, let me know it, please, in the comment below or in the chat. Yeah, I think it's good. And it's interesting that they're doing also the topic before, like vectors and arrays. And I just want to know what is a C-style array by definition, you know. So that's why I want to dive into this topic again. Now that we have covered std vector and std arrays, we will complete our coverage of arrays by covering the last array type, C-style array. As mentioned in lesson 16.1, Introduction to Containers and Arrays, C-style arrays were inherited from the C language and are built into the core language of C++. Makes sense, right? So, yeah. Unlike the rest of the array types, which are standard library container classes, this means we don't need to include a header file to use them. Good to know, really good to know. As an aside, because they are the only arrays type natively supported by the language, the standard library array container types, for example, std array and std vector, are typically implemented using C-style arrays. Yeah, makes sense, right? Declaring a C-style array. Because they are part of the core language, C-style arrays have their own special declaration syntax. In a C-style array declaration, we use square brackets. It's called square brackets. Good to know. To tell, by the way, I'm learning also English here. Kinda. To tell the compiler that a declared object is a C-style array. Inside the square brackets, we can optionally provide the length of the array, which is an integral value of the type std size t. Underscore t. That tells the compiler how many elements are in the array. The following definition creates an C-style array variables named test_score, which contains 30 elements of the type integer. Okay, nothing special here, right? Size is 30. It defines a C-style array named test_score that contains 30 values initialized in the elements, no include required. So the question is, if you're using a C-style array, you need also this /0 thing, right? You need the and thingy, right? Something like this. Or am I wrong? Okay, I keep reading. I'm just keep reading, and then we're gonna see. Defines C-style array named test_score that contains 30 values, initialize integer element, no include required. Then we have the std array integer 30. It's kind of the same. It's for comparison, here's a std array of 30 values initialized in elements required, including array. The length of a C-style array must be at least 1. The compiler will error if the array length is 0, negative, or non-negative value. Makes sense, right? So if it's 1, the index will be 0, right? So yeah, you have to keep also this always in mind. The array length of the C-style array must be a constant expression. Make also sense. It does, right? Just like std array, when declaring a C-style array, the length of the array must be constant expression of type std size underscore t, though this typically doesn't matter. Okay, The length of the array must be a constant expression of types. Though this typically doesn't matter. Wait a second. I'm not really understanding this. Maybe someone can explain me that. I'm keep reading. Tip: some compilers may allow grading of arrays with non-const expel length. What? Okay. Wow, you can do also non-const expel length. Okay, for compatibility with C92 features called variable length arrays, VLAS. Variable length arrays are not valid C++ and should not be used in C++ programs. Oh, dude, legacy code, huh? If your compiler allows these arrays, you probably forgot to disable compiler extensions. Subscription C-style arrays. Just like with a std array, C-style arrays can be indexed using the subscript. Is it called subscript operator? What was the name for the brackets? I already forgot it. Square brackets. So operators with operator square brackets, right? Okay, we have this one. Then we say, okay, it's a size of 5, and then we have array. So we're saying on the position 1, so there's a second position actually. We want to have the value 7. So array 0 will be 0, or it's not defined. And use subscript operator to index array element 1. Yeah. And then we're going to print out 7. Yeah. Makes sense. So unlike the standard library contains container classes, which is use unsigned indices, right? Or how it's called. Let me check. Indices. How I have to read this? Maybe someone can help me. Right. I need this. Come on.
Indices.
Yeah, so then it's correct. The index of the C-style array can be either a signed or an unsigned integer. Okay, makes sense. Or an unscoped enumeration. Oh, dude, now it's getting unscoped enumeration. What is an unscoped enumeration, boys and girls? Need the better. For the unscoped enumeration, each enumerator is declared both in the scope of the enumeration specifier. I need haha. It seems like I overjumped the topic. Did I? Okay, no, I did it. Let me read this quick. Unscoped enumeration input and output. In the prior lesson 30.7 unscoped enumeration, we mentioned that enumerators are symbolic constants. What we didn't tell you then is that the enumerators are integral symbolic constants. As a result, enumerator types actually hold an integral value. What? Okay. This is interesting. This is similar to the case with chars. Consider char. Yeah, makes sense. Then we have like a number for that, right? So a char is really just a 1-byte integral, and the character a gets converted to an integral value, in the case 65, and stored. This is sometimes also really interesting if you want to work with the ASCII table or something like that. Yeah, you will find stuff like this in the exam. And if you not have an ASCII table, then have fun. When we define an enumerator, each enumerator is automatically assigned an integer value based on its position in the enumerator list. By default, the first enumerator is assigned the integral value 0. And each subsequent enumerator has a value on the value 1 greater than the previous enumerator. Wow! This is interesting. This is pretty cool. So then you have the color shirt and then you have blue and it's also number. Blue would be then 2. This actually store the integral value 2. Ooh. It's sometimes so cool you reading something up and it makes absolutely sense. It is possible to explicitly define the value of the enumerators. These integral values can be positive or negative and can share the same value as other enumerators. Any non-defined enumerator are given a value 1 greater than the previous enumerator. Okay. What? Really? You can assign -2? Wait. It's getting better and better here. I'm not sure if I like that. If you're saying cat is equal -3, so the others will get automatically defined. And then you can say horse is equal 5. Oh, and then it will be like 5, 6. Share same value as horse. Oh, but wait, this is bad, right? And the chicken will be 6. Is this even good? Interesting. Enum. An enum. Okay. Note in this case, horse and I don't know how to pronounce it, and I don't want to try it.
Giraffe.
Giraffe. Okay. German called Giraffe. Or is it? It's the same, yeah. Okay, let me see. Giraffe have been given the same value. When this happens, the enumerator become non-distinct, essentially. What does non-distinct means even like? Not like, let me see. This is today a really interesting topic. Yeah, that makes absolutely sense that is non-distinct. Essentially, horse and giraffe are interchangeable. Although C++ allows it. Yeah. Hello. Oh man. Assigning the same value to enumerators in the same enumeration should generally be avoided. Makes sense, right? Because it's non-distinct and we know what this means. Nicht eindeutig. Best practice. Avoid assigning explicit values to your enumerators unless you have a compelling reason to do so. Unscoped enumeration will explicitly convert to integral values. Consider following program. Okay, okay, got it. And then we have this color shirt blue. Okay, then we have this 2. Yeah. And then we have shirt. What does this do? Now, give us the 2, right? No. Yes. Since enumerator types hold integrals values as might expect, this prints Your shirt is 2. Okay, nice. It's so funny if sometimes you have a logic about something in C++ and it's just working this way. But sometimes it's not, and then it's getting really spicy, I would say. When an enumerator type is used in a function call or with an operator, the compiler will first try to find a function or operator that matches the enumerator type. For example, when the compiler tries to compile std_cout, console output, shirt, the compiler will first look to see if operator, I don't know how to call this, please let me know in the comments below, knows how to print an object of type color, because shirt is of the type color to std_cout, it doesn't. If the compiler can't find a match, the compiler will then explicitly convert an unscoped enumeration or enumerator to its corresponding integer value. Because std_cout does know how to print an integral value, the value in shirt gets converted to an integer and printed as integral value. Oh, I think this is a really huge topic. Printing enumerators names. Most of the time, printing an enumerator as an integral value such as 2 isn't what we want. Instead, we typically will want to print the name of whatever the enumerator represents. But to do that, we need some way to convert the integral value of the enumeration 2 into the string matching the enumerator name . As of C++20, C++ doesn't come with any easy way to do this. So we will have to find a solution ourselves. Fortunately, that's not very difficult. What is fortunately? Why? Why this name? I mean, yeah, makes sense. Yeah, fortunately, it's easy. It's not always easy, right? It's not always easy. This time it is easy. The typical way to do this is to write a function that takes an enumerator type as a parameter and then outputs the corresponding string or returns the string to the caller. The typical way to do this is to test our enumeration against every possible enumerator. So, okay, let's see. Print caller. Okay, we have this using if else for this inefficient. For this is inefficient. Or we say if caller is equal flags should see output. Okay, got it. However, using a series of the if else statement for this is inefficient, as it requires multiple comparison before a match is found. A more efficient way to do the same thing is to use a switch statement. We dig deep into this topic, right? Why switch statements can be faster. In the following example, we will also return our caller as std_string to give the caller more flexibility to do whatever they want with the name, including print it. So, okay, let's see. Okay, we have our enum caller. And then we have black, red, and blue. I'm two guys. What was the enum? Wait. I'm not 100% right now because I'm asking my question. Wait, what is the enum? Wait. I need the definition quick. In computer programming, enumerator type is a data type considered of a set of name values called elements, members. Okay, what is then the enum versus struct? What is that score in the Google search? It's not that important, but it's like also the data is not completely correct, right? I'm using it sometimes for researching if I'm doing analyzing data, right? So new market and stuff like this, you know. But it's not completely precise, and you can use already the stuff what you getting provided if you're doing, for example, Google Ads. Then you're getting like free information about stuff like that. But it's nice to get like a base number, right? Even if it's not really correct, right? So, but you're getting a feeling how many people looking some stuff up. No, it's completely fine if you're asking, right? So this is like what I'm doing to get, my research stuff to get some money in. Enum versus struct, because I'm not the developer. Enum versus struct. A struct is a user-defined type that will have some named fields that can be of different types. That all exist at the same time. And enum is a user-defined type that can have either elements defined by the user or named fields that can be of different types, and only one exists at the same time. Okay, guys, what is different about struct and enum? Please. I need your help. I'm not really understanding it. I was like, after I just read this up, I was like, okay, maybe I will understand, but what is it different about structs in enum? If I have it like this. Okay, we have already one I don't know. Does someone knows? Huh? I think I'm digging too deep already again. Different between structs and enum. Here we go. I'm a newbie in C++. I'm still also a newbie. Okay, we have this type def thingy. Okay, and then he's doing that one, or he's doing that one. Okay. Here he's doing it with the enum and with type def. I mean, this comparison is not. This is not even equal. But we're just gonna dive into that. What is the difference between them? Why we use one over the other? Okay, let's see. Here we go. Okay, we have one answer in the chat here. Struct is like a group of variables, so you can have a struct for a 3D vector which contains 3 floats for x, y, and z, whereas an enum is like assigning names to numbers. Yeah, but you should not assign it, right? That's what we learned. Only if we have a use case for that. But you could use actually struct also, right, for this. Oh wait, you're correct, man. Struct is like group of variables, so you can have a struct for 3D vectors which contains 3 floats for x, y, and z. Wait, let me think quick about this. Hold on, let me make an example. Okay. I'm gonna read this meanwhile. An enum lets you declare a series of identifier, right? This is the identifier thing, right? For use in your code. The compiler replaces them with numbers for you. So it's like, it's the same, the thing with this char thing, right? What we have. If I'm understanding it in the correct way. It's often useful for making your code more readable and maintainable, because you can use descriptive name without the performance penalty of string comparison. Aha! It can also make the code less bug prone, because you don't have to keep writing in a specific number everywhere. Which could go wrong if a number changes. So you not have it for the struct? Okay, I'm getting it. I think I get it. A struct is a data structure at its simplest. It contains 0 or more pieces of data, variables or objects, grouped together so they can be stored, processed, or passed as a single unit. You can usually have multiple copies or instances of it. The struct can be a lot more complex though. It's actually exactly the same as a class in C++. Except that members are public by default. Yeah. Why it's different, man? Why it's different? Come on. Why it's different? Instead of private, like a class. A struct can have member function and template parameters and so on. We know the answer because of backwards compatibility. Oh, man. Okay. One of the vital difference between structs and enums is that an enum doesn't exist at runtime. Okay. It makes sense. It does, right? It's only for your benefit when you are writing the code. However, instances of structs and classes certainly can exist in memory at runtime. From a coding standpoint, each identifier in an enum doesn't have its own type. Every member with a struct must have a type. Okay. I'm just checking the code example here. So let me see, boys and girls. Okay, your example here. Why are you using passbin? I mean, you could use also... Okay. You have your enum class. Exactly. But you not have to do this, right? It would do it automatically. If you... Wait, you can do even enum class? You could do the assignment. It would assign automatically, right? So let's say you have a weapon and you want to check its type. You can do don't want to have to say if it would. Yeah, but it's just you just did it for. Yeah, I got it. Struct public, and then you have this class. Okay. Aha, interesting. Okay. Would you use the enum if you want to get like UTF-8 or something from the ASCII table? No, right? You would do it like in a different way. Forgetting like, for example, you know, the stuff, other languages. I'm not sure what you mean by that. I mean, because if you have the ASCII table, you're missing some letters for other languages. So how you... No, probably it would not... I mean, you could make your own ASCII table then, right? Or am I mixing stuff up? Probably I'm mixing stuff up. Not sure. I just thought about it, right? Because they bring up the example. So we keep going. It's funny that we just ended in this kind of topic and I not even planned this out. Yeah, C++ programming is so much fun, right? Isn't it? So we have enum color, then we have black, red, blue. Okay, we have that. Okay, and this is, we know this is like, can we say it's like on compile time? That it can't be on runtime, so it's more performance-wise also better. Kinda, compared to struct. What we have here now, should string get color. Okay, this is also, and then we have the switch case is what we have, right? I see. We have never had to deal with that. Should string is UTF-8. I believe so. I think it supports other languages already. Ah, okay. Makes sense. So what do you develop in, by the way, Disco? I'm just gonna call you Disco. I hope it's okay. So, should string get color. We checked it in assembly why this can be faster, right? I should redo this topic again. Kekwiga, how are you doing? When is my exam? So, guys, do you know what I did yesterday? Guys, do you know what I did yesterday? I cancelled it. But wait, 1 second. 1 second. I canceled the easy one, right? Because I have to rewrite it. And it's my last attempt. And I gonna call you why. The reason is probably the exam would be easier. Way easier than the exam before. But I was not able to visit the lectures only one time because I have already new lectures and it's another professor. And I just decided to write this exam by the same professor next semester. Because it's adding like a risk for me, you know? Even if everyone is thinking the exam is way easier. And it's freaked me a little bit out that I not, you know, was able to visit, or like like able to visit the lectures. I could visit them, but probably I think I just want to be safe. You know what I mean? Sadly, I can't do that. Yeah, but the thing, I had like no problems to write it, but it's freaked me a little bit out. And I had like also some discussion with some one guy in this class, and then, you know, I was not sure should I write this exam by this professor, because I not visit his lectures and maybe he's putting the focus on other topics and then I'm screwed over. I don't know. Actually, it should be. I mean, I'm over 300 hours in C++. The topic was only like you getting, the exam actually was just you getting some question about arrays and stuff like this. You're getting like a wrong code. You have to say what is everything wrong in this code. And then you have this and the logic gate stuff, you know, and that's it. So I think the exam is not difficult. Way easier than the other exams, but you never know, and I don't want to risk it because I not visit the lectures. So it was for me, it added kind of risk, right? It was like computer science stuff, informatic, like 1, you know. The second one I'm gonna write. The harder one I'm gonna write. I know it's make not that much sense because, you know, if I'm able to finish the harder exam, then it's like, but still I have to redo the first one. So I'm gonna write the second one, but have to redo the first one. And it was just, it freaked out me a little bit, because back then, because you know that I studied already, I failed one time an exam because just the professor switched. And I was like, yeah, okay, I learned really good for the exam. And then, the professor shifts also like the focus kinda, And then I was screwed over in the exam. And I was like, I go in, I just learned 3 months easy going, And then I went into this exam and then turned around the piece of paper. And I was like, okay, okay, number 1. Oh no, let's go to exercise number 2. Oh, okay. Go to exercise number 3. Okay. This is not looking good. So, it was literally something like this, and I was like, oh no. How many times have you done it? Only one time and I failed it. So you in Germany you have only 2 attempts, right? If you're failing 2 times, it's over. And last time I failed it because they said it's in C, right? And the topic will be not no pointers. It will be in C, and you have to write something and you have to return the array, correct? So how are you gonna return an array from a function, a C-style array from a function that without pointers? And then the answer was like, yeah, you can use for that you can use vectors. And I was like, I can use vectors. Oh, good to know after the exam. Good. I was like, thank you. but at least now I know how to return like C-style array from a function. So, but yeah, that screwed me a little bit over because you needed this value, like the returning thingy, to finish the full exam. And instead that I said, okay, I just use some imaginary numbers and keep going through the exams, I try to return the array without pointers. C-style array without pointers. Yeah. I mean, I just checked also to be honest, I just checked also the statistics, and it was like something 2 people were able to complete the exams and then 3 more and the rest just failed. Like, yeah. I think the most people had like the problem to return the array. Yeah. But it is what it is. Exams can be hard, can be easier. Sometimes you have the correct approach. Sometimes you just realize in the end of the exams your approach was not correct. And I think there are also some people, they have like a certain skill. They're really good in writing exams. And I'm not one of them, to be honest. No. Sometimes it's just better in the exams if you know if something is wrong, just write it down. Yeah, I did a mistake. I will keep calculating or doing this exercise with this kind of number, with an incorrect number, and you keep going, because then you're still getting points. But if you're trying to fix too long to solve what you did actually wrong, you're probably gonna fail the exam, right? This is just if you're not able to fix your problem. So that's a skill by, yeah. Some people have the skill, some people not have the skill. I mean, it's just a skill issue. Kekwiggler, how was your exam, by the way? Your MATLAB thingy. So we keep going here. As of C++20, C++ doesn't come with an easy way to... We did this already, right? Yeah. Okay, we have to go down. It was this here with the switch statement. Then that's were not good. Question I fucked up. The thing is, sometimes in exam writing, you have to be just better than the average people, and then you are fine. Okay, there's some exams, if you're studying tech, that the number will be 4.8. So the most people not making it through the exam, then the average is not enough. But most of the time, if you're better than the average percentage of your class, you're gonna make it through it. So I remember one time I write the exam and I was so sure that I did it and I failed. And then I wrote the same exam and I had like the feeling, okay, I failed my second attempt. It was so much worse than the attempt before. And I was like, okay, I have to write the professor whatever. I have to ask for 3 times, going through this process that you are able to write it, not the second time, the third time. And but I made it, right? And I was like, how? Because I was probably just better than the average of percentage of the people on the day. But it's fine. My other exams were good. Okay. Do you know any online test for C++ to evaluate your skill level? You talking about this has made me want to know my skill level. What do you mean? Online tests for C++. I think that the problem about is I mean, C++ is such a big language, and if you wanna, what is the correct word? Test someone, right? You could ask question what you know, and you actually know that they're gonna fail. It's not hard, right? You could do something like this. Why is the vector object bigger than the string object? If you're using size of, what we went through this topic last time. You can ask a question like this. I'm pretty aware of that not a lot of people know this. You know what I mean? You can go really deep in C also and ask basic question. How is this if you're writing something like this in C code? How is this looking in assembly? Why it can look different? What's the reason because of that? And so on. That's sometimes the problem about tech, because you can, yeah. If you just shift the focus, the exam can be for a lot of people way harder. Just my opinion, I don't know. There are like 15 people on this course, so yeah, I mean, if you have the half of the question correct, you can make it through the exam. Oh, then Kekwiggler, you're really good then. Okay, keep going then. Okay, here we go. But guys, do we have here some people that actually like to write exams? I don't know why, but I kinda hate it. Because of that I failed so many times. I was always also in school one of the guys that I was most of the time not in the middle. I was always like really really good, like number 1, or I was like really really bad, more like 4. But in between, you really like it. Oh, I'm not liking it. I don't know why. It's stressing me so out. I mean, it stressed me so much out that in the past, some exams I failed because I was so stressed out. In some exams, they was not even that easy. I was like, I'm just trying it, right? I was completely chilled, and I make it through the exam, you know. And the other one I just failed because I was just, I'm 35 years old, and still I'm getting like, and don't want to say like hyped up for exams, but you get my point, right? I don't know. I'm not good in it. It's just like, I'm trying to work on it, but I'm not really good. Did you have such great personality you could actually do such good content? I don't know. The problem is also my English is not really good, to be honest. I mean, this is a huge problem. Yeah, a lot of people said, "Why are you still studying? Why are you still trying it?" It's a painful way for me, but I'm trying to break through my disability. Is this even a word? I mean, to be honest, back then I had like exams, and after the exams, right? For the next exams, the professor even asked me how you failed the exam before, because in the lecture he just said, okay, what is the solution? I was like, you have to do this and that and this, and then you have to be aware of that, and then boom boom, finished, and he was like, how you failed the exam? And I was like, I'm not good in writing exams. I don't know, what should I do? Sometimes I'm panicking, and then guys, do you know what freaks me out? Sorry if this is right now a little bit off topic, right? Do you know what freaks me out? If you're doing something, right, in tech, for example, you have to calculate something, right? And then you realized, okay, you should get something. Is it called kilograms, right? It's called kilograms, right? Kilogram, yeah. You should get something like 40 kilograms or something, and then you're getting a number like 60 tons or something, 66.6 tons or something, right? And then oh no, you fucked up. No, you fucked up. And then you're checking the time. Oh no. And then you're going into the cycle, right? Should I rewrite everything again, or should I check what I did wrong? Sometimes it takes a bit to figure out of express what you already know. Okay, not to be cringe, but look how much your brother lost, but he comes out better than most because he stays hardworking and he knows that what he's doing. Yeah, my brother is like... I had my last ever exam yesterday. Good job. I hope one day I make it also to the other side. We're gonna see if I'm able to do it. Oh man. But to be honest, for the next exam, I'm hyped. For the C++ exam, I'm hyped. The C and C++ exam, I'm hyped. I think I'm kind of good prepared. Yeah, for this one, I'm... Yeah, that's my problem. You can't be perfect. That's my problem. What I have sometimes that I'm like, if I'm spending 10 more minutes, I can solve literally the problem, and then I will have a really good grade or something. You know what I mean? And then okay, 10 minutes are over. Only 10 more. I'm so close to solve the problem. And then you're getting in this rabbit hole, And then you're ending up, now I have only 20 more minutes. Now I can't keep doing the other exercise for the exam, for example. Right? And then you completely committed. You know? And that's the reason why I failed so many exams. And there are some people that are saying, okay, this is not 100% correct. Fuck it. It doesn't matter. I would just keep doing it with this wrong number or whatever and keep doing it. And they make it through the exams. I mean, thanks, Sven. Oh. Oh. And good luck. Yeah. I'm happy for that. I think it's also sometimes if you are successful, like doing exams, you're getting used to it, right? You're getting better and better and better. It is what it is. I mean, you can't be good in everything, but you can try to get better. Yep. That's why I'm learning C++, huh? And then I'm gonna get replaced by AI, you know? I mean, actually, I want to go into this AI thingy a little bit. There are really good contents, not content creators, but YouTubers, I would say. They're making really good content. And it seems like if they're too techy, right? They're not getting a lot of views, but actually they're providing like insane amount of value. But you need also like some base knowledge about math to understand what's going on. I'm getting it. That's the reason why not a lot of people watching them. Alright, bad for me. It's almost 9 a.m. Have a good day, man. Okay, let's keep going with the C-style array. Kek 7, man. My brother doing also really well. Maybe he will achieve the 16k. I don't know. I am a believer. It's official. I'm a believer. I believe in my brother. Okay, where was it? I have to go back to the topic. So we have the switch stated here. I don't know if you have 4 switch statement, probably you will not have like performance-wise a benefit out of that. I'm not 100% sure. So yeah, it is what it is. So we have the color. Okay, got it. Oh, I'm remembering back then that I realized what you can even create then if you're doing stuff like this, an object inside this thingy here. Okay, then we have the switch case like color, and then we have case black, red, whatever, and then okay, fine. This is completely fine. Okay, then we have color shirt. We're gonna say it's blue, and then we're getting because we're calling this function, right? Oh yeah, that makes sense. That's cool. Like it, okay. Here we go. This likely performs better than the if-else chain. Switch statement tends to be more efficient than if-else chains, and it's easier to read too. However, this version is still inefficient because we need to create and return a std string, true, which is expensive every time the function is called. In C++ 17, a more efficient option is to replace std string with std string view. Std string view. Std string view. Yeah, std string view is pretty good. It has also some downsides, but it's pretty nice. Allow us to return string literals in a way that is much less expensive to copy. So we have IOStream string view, then we have our enum, black, red, blue. then it's a const expr. And what we learned, actually, what I watched a YouTube video and it was really interesting. It says, okay, const expr can be like on compile time, but it's not guaranteed. If I'm understanding it correctly, it's not guaranteed that this will be on compile time. Right? Please correct me also in the comments below if I'm correct or wrong. So then we have std string view, so we're not generating a copy here, get color, blah, 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 whatever. Then we have this, and then we're doing the same thing again. We're just doing it with std string view because then we're not creating a copy, yeah. Otherwise we would just create a copy, correct. Yeah. Teaching operator. I don't know this name. Sorry. How to print an enumerator. Although the above example function, well, we still have to remember the name of the function we created to get the enumerator name. While this usually isn't too burdensome, it can become more problematic if you have lots of enumerations. Using operator overloading sometimes, guys and girls.
Capability.
A capability similar to function overloading. We can actually teach operator, whatever, how to print the value of the program defined enumeration. We haven't explained how this works yet, so consider it a bit of magic for now. Learning C++ and English. Yeah. But actually for programming, I think it is good to do it in English. Last time I just read the script from a professor, and it was good. It was really good. I really like it. But in German, it's, I don't know. Sometimes it's weird because it's getting translated into German, and then you're just still using the English stuff like enum or whatever. You know what I mean? It's not feeling right. Sorry. It's not. It's. Yeah. Okay, we have this. Okay, let's see. Enum, black, red, blue. Teach operator how to print a color. Yeah. We're doing it with the operators then, huh? Yeah. Nice. Consider this magic for now since we haven't explained any of these concepts it uses yet. Std outstream is the type of std cout. By the way, if you don't know, cout means like console output. The return type and parameter type are references to prevent copies from the being made. Sorry, okay. Yeah, we have the reference here. Yeah, and then we're going to define it. Yeah, nice. Wow, you can do it also like this. This is interesting. Huh. This is cool. I was not aware of that you can do something like this assignment for operator outside of a class. But it makes sense. By the way, Kekvikler, what you studied? Color shirt blue. Yeah, then it's gonna work. Yeah, perfect. Yeah. That makes completely sense. And we're gonna create this object, right? Here we have the object. And here we define the object. And then we have that one. Oh, nice. I'm starting to like more and more C++. C is also really good, but this is... Yeah, I just asked you, what are you studying? For advanced readers. For the curious, here what we above code is actually doing. Here's what the above code is actually doing, sorry. When we try to print shirt using std cout and operator, whatever, the compiler will see that we have overloaded operator, whatever, to work with object of type color. This overloaded operator, whatever function, is then called with std_cout as the cout parameter in our shirt as parameter color. Since cout is in reference to std_cout, a statement such as out operator blue is really just printing blue to std_cout. Yeah, makes sense. Chemistry. Ooh. Actually, chemistry is really interesting. I mean, tech is interesting, right? But in school it was like, But I think you can do really good stuff with chemistry, right? But nowadays you have to maybe the people nowadays have the problem that they have too many information. It's overwhelming. You know what I mean? Back then you have to go in the library, getting the right books and stuff like this. But you have every day so many new scientific papers released. You could read forever. But I do computational chemistry, so I have to learn Python soon. Yeah, and probably also this. I think in chemistry there you will have a lot of nowadays AI maybe to get new chemistry. I don't know how the word called. Chemische Verbindungen. Da war doch mal was. I think there was an experiment about chemical compounds what the AI just created because they just connect and they just found a new one. Machine learning, yeah. Machine learning is actually interesting. I want to go a little bit more deep how the tech is working. The problem though is if you want to you can actually forget it to make your own model. If you want to achieve something, whatever, right? But what you could do, you could retrain a model, but still then it's expensive, right? I think you need still 1-2 million or something to retrain a model. And you need also the data, of course, right? This is also I think it's more 2 million, right? That's why it maybe sense to go to university and learn something. Maybe university just spent on this topic 2 million or 3 million euros. But if I'm correct, we have maybe it's changed. But now, right now, we have in Europe no capacity to train a model like ChatGPT. So the array length of C-style array must be. Oh, sorry, we are not there. We have to go through this topic. So we covered overloading the input-output operator in less than 21. Yeah, we did it. Did we? Yeah. For now, you can copy this code and replace color with your own enumerator type. Enumeration size and underlying type base. Sorry? I think that was the pizza. Enumeration size and underlying type base. The enumerator of an enumeration are integral constants. The specific integral type used to represent enumerators is called the underlying type or base. For unscoped enumerators, the C++ standard does not specify which specific integral type should be used as the underlying type. Okay, this is really interesting though. Sometimes you have to read stuff twice. Okay, I think I got it. Most compilers will use type integer as the underlying type. Okay, meaning an unscoped enum will be the same size as an integer, unless a larger type is required to store the enumerator's values. Ah, okay. Getting the point. It is possible to specify a different underlying type. For example, if you are working in some bandwidth bandwidth, right? Sensitive context, for example, sending data over network, you may want to specify a smaller type. Yeah, makes sense. Use an 8-byte integer as the enum underlying type. Okay. Okay. How big is an enum? It's if you have like, it's an integer, right? So, okay, let's talk about this topic. Could be also interesting. So if you have black, red, blue, right? And you know it's aligned with a number. So you will have, how is it, 0, 1, and 2? And 3? No, only 0, 1, and 2. So it's would we initialize all 3 of them, right? We would allocate the memory for them. So it would be like, if it is an integer, it will be 4 bytes, 4 bytes, 4 bytes. If we have a 32-bit system, so it would be then 4, 8, 12. Correct? No, it's not, because we have this padding thingy, and it would have like 8 byte. Right, at a 32-bit system, 8-byte sequence. So we would have, like, in the first block, we would have this one. And then we have blue in the second. And the rest would be empty. The rest, correct? Yeah. Am I correct? Am I mixing up again? What is one sequence? 4 8-byte. It's 8, right? Oh, I should rewatch my video from last time. Give me a second. Give me a second, boys and girls. Before I'm mixing up stuff, and that's not correct. I think that would be not good. Hello, everyone. Yeah. Wow, that was loud. So let me see. Where is it? Where is it? Come on. I'm pretty sure that I watched a YouTube video or something at some point. I don't want to watch it. Here we... no! Clicked it away. Okay, it was 4 bytes, right? In a 32-bit architecture. Structure padding. Yeah, then it would be 12. Would it be? No. 4, 4, 4. Yeah, it would be 12 then, right? I'm gonna rewatch it quick again. I don't want to share wrong information. Structure, padding, C.
In this presentation, we will try to understand the concept of structure padding in C. So let's get started. How memory is allocated to structure members? That's a very important question. Has been allocated to this character, then this character.
Yeah.
Now what is the size of struct ABC? That's the question. Is 4 bytes. Isn't that so? But let me tell you that this is wrong. You are wrong here. There is a concept called structure padding which we have to understand here. Processor doesn't read 1 byte at a time from memory. This is very important for us to understand that processor doesn't read 1 byte at a time from memory. It reads 1 word at a time. Now what does this mean? What is the meaning of this 1 word? If we have a 32-bit processor, then it means it can access 4 bytes at a time, which means word size is 4 bytes. If we have a 32-bit processor, then it means it can access 4 bytes at a time. Instead of accessing 1 byte at a time, it can access...
Yeah, then we would have 12, right? Is it working like this? I guess, right. So we would have 12-bit bytes for this scenario. Correct? I assume so. No, it's not working like this. No! Okay, why? So enum's working differently then. Because we learned already, like, this is an integer, this is an integer, and this is an integer, right? But here we're using an 8-bit integer. Oh. So we would have, this would be only 2 then. No, wait, 8-bit integer is 1 byte then, right? So each of them is only 1 byte. Correct? So we would have then this enum would be something like 4 bytes? Is this correct? If I'm... No? Okay. Am I even close? Enums don't hold... So an enum is more than like a union. Ah! So it's gonna... okay. Then it would just use the biggest one. And would, in this scenario, we would hold only... So if it would act like a union, it would take the biggest object in this comparison, and we would like have this 8-byte integer. 8 bytes would be in a 32-bit system 2 cycles. So 2 cycles would be no, it would be 1 cycle. So it would be 1 bit, 1 byte. And to store the 1 byte, so we would have 1 byte and 3 empty thingies. So it would be in total 4 bytes. We have to use for this thingy one cycle. Correct? So okay, sorry guys, this was not really good from my explanation. So we would have like... Is it not working like instructs? Yeah, it's 1 byte, correct. But the thing is that I made, I don't know if... You know this video here, right? We did this topic yesterday. That because of the sequences, that you would have it like, if you want to exit it, right? No, wait, I'm gonna show you the scenario. So this is like a 32-bit architecture. So 4, 4, right? The thing is, the problem is that we could have other stuff stored in this architecture stuff, right? And then we would have no access to it. That's why A, B, and then we would have like 2 empty thingies and C separate. Yeah, I know, but the compiler can decide this stuff for itself. You can force the compiler to put everything next to each other. Yeah, of course you could do it, but the thing is it wise to do though? But it's slower. I know you could do it. But if you're not forced the compiler to for that, then we would use 4 bytes for the one sequence on the 32-bit system. Correct? What I didn't really understand is, okay. Ach, you don't understand why it's slow or what? What I didn't really understand. Okay, let's watch it, rewatch it, maybe then.
This means that integer c, right? What's the problem here? Problem is that in one CPU cycle, character A, character B, and 2 bytes of integer c can be accessed, right? This means that in one CPU cycle, one word can be accessed, right? If I'm considering 32-bit architecture, then word size will be 4 bytes, right? This means that in one CPU cycle, 4 bytes can be accessed. So, character A, character B, and 2 bytes of integer c can be accessed at a time in one CPU cycle, right? And there is no problem with character A and character B.
But
in
we
one
see
CPU cycle, both the variables can be accessed easily. There is no problem with it. But whenever we want the value stored in variable c, 2 cycles are required to access the contents of variable c. Here in this case, suppose we want to access this variable only, right? Then one cycle is required to access these 2 bytes and one cycle is required to access these 2 bytes. So total.
But the thing is, if you're using enum, does this even matters? Because if you say it's like more acting like a union, we will have only access to B or A, if we define it, right? Because it's getting only for one of these can we say objects like memory allocated. So does this even matters? I don't know.
2 cycles are required to access this variable c. Isn't that so? In first cycle, only we would be able to access first 2 bytes, right? While in the second cycle, the last 2 bytes. Because in one cycle, these 4 bytes can be accessed. And in the next cycle, rest of the 4 bytes can be accessed. In the first cycle, we would be able to access these 2 bytes only. And in the second cycle, we
X29, how are you doing, man? I'm fine.
would be able to access these 2 bytes.
The video is talking about it when it is used, but the basic types don't change the size because they get padded. You wouldn't say that the char is 2 bytes in size just because they are 4 bytes. You wouldn't say that the char is 2 bytes in size just because there are 4 bytes used before the C variables. So if someone would ask you this struct, which kind of size this struct will have, what would your answer would be? My answer would be then, if you have this combination, it would be 8 bytes, right? In a 32-bit system. In a 64-bit system, it would be 18. So you would answer, no, you would not answer this like that? Oh, 16, sorry. Yeah, sorry. Guys, I just want to test Lettermate's math skill, or just to check you, man. Well, at least you're not studying math, right? Physics people are a little bit more chilled. No, actually, you could say they are. Could you say they are even more hardcore because you have to prove everything, also like in a real world scenario? You could even say that it's more like hardcore, It depends, right? Integer is usually still 4 bytes on a 64-bit system. I thought it's 8 bytes then. Nah, physics are less hardcore. In theory, maybe. But in my opinion, if every professor what I met, I mean, also like the math professors, like kind of really precise and all this stuff, But the physics people, I don't want to say they're living in another universe, but they are also like, they are like I think they have a high value, man. I have huge respect. Huge respect. I mean, what they can do everything, man. I mean, hello? Math is really in depth. Physics people just pretend everything is a nice function and life with that. Ah, okay. And usually they are right. I met the thing is we have one professor. He's also have doing lectures in a elite university or something like this, and he's tough guy. Kind of special, but yeah. But I have respect to this kind of people that just committing their full life to a topic like that, right? And I think they also deserve the respect, right? I don't know what your opinion is about that. If someone commits his full life to one topic or whatever, maybe you should not argue with them, like, well, like, yeah, they can do a lot of. I have so much respect. I remember one time, I don't know what the topic was. It was for me so cool because also the people that studied math and informatic, they're also 5 heads. This is also crazy. But there was one case, someone have to make or had like a speech or something about the topic, and he was not sure about the topic, and the topic was actually a tire, right? From what was the topic? It was a tire and how if the tire is gonna act with the ground, what is gonna happen and whatever. He wasn't completely sure about that. What is gonna happen on the tech side completely. And this and then this physics professor was like, okay, let's try it. Okay, we assume we have that one. Ah, interesting. And then this and this could happen. Ah, okay. And yeah, now we have to prove it. Blah 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 blah. And 1 hour later, and I was like, ooh. I mean, this was sick, right? And do you know what sometimes I like about engineering or physics stuff? That they're saying, okay, yeah, this is also important, but we can cut it out. For this scenario, it's not that important to use this variable or something like this. And then they can just simplify things, right? That's also really cool. Otherwise, it would be really hard to compute this kind of process. Knowing an incredible amount of complex math is not useful in itself until you do something like physics. I would not agree with that also totally, because we have had on the other side a math professor. He studied informatics and math, and this was. It was like, I remember what we did like. We had like a topic and we not really understood it, and he just programmed it and visualized it with OpenGL or something. And so, you had last time problems to understand it. Okay, I just have here a little program it like that, and now you can see what's going to happen in real life scenario. And it was like, oh, okay, nice. I mean, that was cool. Okay, now we can just manipulate this, what is called amplitude.
Amplitude.
We can now just manipulate this amplitude, and then we can even manipulate this one, and you can see what's gonna happen if we pretend that I programmed everything correctly. He said, you know, this was so sick, man. I was like, wow, cool. Sure, we need math professors, but they are not on the same level as. I don't know. I have both of them like respect, like huge respect. think I have to. Everyone has huge respect that spend a lot of time and know some stuff, right? Even if you have an engineer and he's really good in technical, what is like technische Mechanik? Is what? Technical mechanics. Also respect. It always depends, right? Okay. Keep going with the topic. I'm drifting up again. I think sometimes, people don't like stuff like this, or people like them because they feel like, or they maybe for them stuff is easy, but for the students it's really, really hard because they have such a skill issue. You know what I mean? It's the same if you're doing sports already for a year. You started with the sport like you were like a kid, 5 years old, and then you maybe someday you're gonna teach someone this sport thingy, and then you realize they have huge problem with for you simply a task, but they're not able to do it. And then sometimes you even have to think about it, how you're actually doing it, that you're getting this kind of outcome, because for you it feels so natural. That makes sense. Okay, let's keep going. Enumeration size and underlying type base. The enumerators of an enumeration are integral constants. The specific integral type used to represent enumerators is called the underlying type or base. For unscope enumerator, the C++ standard library does not specify which specific integral type should be used as the underlying type. Most compiler will use the type integer as the underlying type, meaning an unscope enum will be the same size as an integer unless a larger type is required to store the enumerator's values. Okay, makes sense. What is my next project? My exam. It is possible to specify a different underlying type. For example, if you are working in some bandwidth sensitive context, for example, sending data over a network, you may want to specify a smaller type. We can talk about new topics after my exams. So we have this one. Yeah, the thing is, we're doing C++, but it's more like a mixed up between C and C++ in a C++ environment. And I'm not sure if sometimes that I'm liking that, because it's also kind of confusing, if that makes sense. Because sometimes it's like, okay, we're using that, but actually we could use the new C++ features and it would be way more efficient. Just saying. No, I would not say they are bad in C++. I know why they're doing maybe the C environment. I'm not calling that someone is bad, right? If you're coming, for example, from a microcontroller background, I don't know if you need so much C++. You could just use the C++ features, what makes sense to you, and the rest you can just cut out. I'm getting it, But if, for example, of course, if you really like the language and if you're seeing this code, you're saying, "Oh, why not? Oh, please, no." I'm understanding that. But if you're coming from a microcontroller background, like an embedded system programming background, I can understand that they like using more the C style approach. I really get it. So it would be also be interesting, right? Because you have probably different compilers if you're in the embedded system world. So I don't even know if you can use then all the C++ features. Maybe you have some guy here on chat or on YouTube, I don't know. So we have that one, CST integer IOStream, use an 8-bit integer as the enum underlying type, enum color stood, okay, we have this, okay, blah, blah, blah. And then we say color, C, black, so and then we're gonna print it out. Size of C, let's see what will be the size. Interesting, okay. Prints 1 byte. Yeah, I had like in exam, I would have here a problem, right? Because I could end up to write 4 bytes because of this sequence cycle things. I would not know what should I answer in the exam, to be honest. In programming, the only thing that matters is that your code works as intended, as no bugs, is scalable, and meets the requirements. I think you're correct, but if you're working with a lot of people, I think it does matter, right? Maybe to say, okay, I think it depends what you're developing in C++, but if you're, for example, developing something else like a web server, maybe then you should use, or like in a gaming engine, maybe then you should use the latest features if they make sense, right? Then you should not do that much old school stuff, I would say, if this could be more risky or whatever. But I think this is also kind of the problem with backwards compatibility that you could have, like in this programming world, C++ programming world, a lot of people that are not willing to upgrade their knowledge. Yeah. So warning, because stood integer 8 underscore t and stood integer u integer 8 underscore t are usually types alias for char types. Using either of those types as the enum base will mostly likely cause the enumerators to print as char values rather than an integer values. Okay. Okay. Integer to unscope enumerator conversions. Alter, heute geht's mal wieder richtig ab. While the compiler will explicitly convert unscope enumerators to an integer, it will not implicitly convert an integer to an unscope enumerator. Oh, this sentence, I have to read it again. This is... While the compiler will implicitly convert unscope enumerators to an integer, it will not implicitly convert an integer to an unscope enumerator. Okay, that makes sense. The following will produce a compiler error. Let's check. Enumpad, no specified base. So we have cat, blah, blah, blah. Okay, so then we're going to say pad, and then we say two. Yeah, okay. Integer value 2 won't implicitly convert to a pad. Yeah. Yeah. It's not working the other way around. There are two ways to work around this. First, you can force the compiler to convert an integer to an unscope enumerator using static cast. Of course, if it's not working, use static cast, like always. No specified base, so we have the same, and then we're using static cast, and we have pad to convert integer 2 to a pad. Okay. And then we have here pad is static cast pad 3, or pig evolved into a whale. This is cool. This is cool. This is funny. Okay. Maybe I'm getting already weird if I'll find something like this funny even. Some people would say it's Spencer. How are you doing, man? We will see an example in a moment where this can be useful. Second, in C++ 17, if an unscoped enumeration has a specified space, then the compiler will allow you to list initialize an unscoped enumeration using an integral value. Okay, here we go. Enumpad, blah blah. Upa. Was ist das denn? Enumpad. What is this, man? Is this even new for me? It's just a list initialize. Okay, it's not new. Calm down. It's not new. I got it. Guten Tag. Dir auch, wünsche ich auch. Programmierst du auch, mein Freund? No, it's not a list initializer? Hey, wait. What? We just specify, okay, what is this? I'm not 100% sure. Okay, can't raise in. So we have a we specifies the base, right? So then we can do this here. We can say pad 1 is 2. So we say pad 1 is 2. 2 is like, okay. But this is weird. What is this topic called? Why I'm confused? Maybe just random scrolling up. It was this here. Yeah, okay. Yeah, okay, got it. Did I? I'm not sure about just realized that. What is the name of this topic here? Like that you can make a double point integer? Is this then called just the base? Yeah, I know that I know this, but I just realized I know what's happening if I'm doing this, but I just want to know if there is like a name for this if you're doing double point and something, you know what I mean? Can specify the base type with that, correct? Yeah, no, maybe. Boys, if I'm not getting an answer, I'm gonna ask ChatGPT. Just want to figure it out. I just want to figure. Sometimes I just realize that I'm missing some topics, right? Some knowledge. So I want to be aware of that. I'm not missing a topic here. What I should covered before. If you're getting my point. Just don't wanna miss a topic. So I'm gonna check it out. Ah, okay, that's only enum specific or what? We're gonna read chat quick. Give me a second. That's behavior, yes. Ah, okay, it's just an operator that's defined for enums or what? Can you say it like that? Still doing enums? Yeah, we like enums. Do you not like enums? Perfect. We had also a deep talk about a lot of other stuff. I just drifted a little bit, right? We did some drifting here. We had some real life, not discussion, however, like conversation. I would call it like that. So it's then just for the enum thingy defined. Like, is it like just for the enum like operator or something? Yeah, I keep going. I know that I can define the base with that. I can live with this. So it's just the way C++ want you to define the base. Okay, then it's good to know. They could have told everyone to write enum pad, dear compiler, please make it. Okay. And that would be fine as well. But you may see how this is a dumb way to do it. No, it's just like why I asked it like this. Maybe it was for some people also confusing why I'm asking this. I just want to know if this is a generalist thing or not. Because I know sometimes we all know by now C++. Yeah, and that's why I'm asking. So if it's like enum thingy, yeah, okay. For defining the base, I can live with that. You know what an enum class is yet? It's used to define the type. Yeah, we know it with this. That was my question what I had before. I just realized where I started with the topic. What is the enum if you compare an enum with the struct? Right. So then we have it. This time rate brace initializer with an integer. This is gonna work. This is not gonna work. This gives me also a compiler error. Okay, compiler error cannot assign with an integer. Okay. But with that one, it's gonna work. Interesting. Okay. So keep going. Unscom enumerator input. Because pad isn't program defined type, the language doesn't know how to input a pad using std console input. If you're going to use an enum, it's highly recommended in modern C++ to use an enum class instead of just enum. It has better type safety. I will check it out. Thanks a lot for mentioning it. By the way, what you're working? Like, are you like probably you're developer, correct? And what are you developing? Just my question. So we have enum pad, cat, dog, pig. Well, and then we have that one, and we're still getting the okay. Okay, we can't print it out. Makes sense. It does, right? Input a pad, yeah, correctly. We have to define it. The workaround this, we can read an integer and use static cast. Okay, with static cast, it's working. Okay, to convert the integer to an enumerator of the appropriate enumerator type. Oh, interesting. So if this is this, I don't know if I'm so happy with this design choice, right? But Could we not do it also with overloading? Probably we could. So enter pad, blah, 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 input, and then we would say 0, 1, okay. And then input the integer, and then we can use pad, static cast pad, and then the input static cast our integer to a pad. Yeah. Good. Because we have this assignment, and then this is going to work. For advanced readers, similar to how we were able to... here it comes. To output an enum type above, we can also teach operator how to input an enum type. I mean, I do whatever I want at the time. I have delved into kernel mode programming and protecting process from DLL injection and other anti-cheat stuff, also into Unreal Engine mods and exploits. Just messing around with some single player games, like seeing how they shoot the gun by reversing the function using IDA and trying to make a rapid fire, for example. So, but this is not your job, right? Isn't it? Are you working for a company to test stuff like this, or is like programming just your hobby? Or you just retired and that's it? In Germany would say, du hast die Schäfchen schon im Trocknen. So now we have this one. Consider this magic for now. Blah, blah, we have this one. Yeah, and then we would just define it. We have the input. We initialize it with this default constructor. Then this input an integer, correct. And then we have it here. Okay. I mean, don't underestimate the young people. It just... I would never do it, man. Most of the time they have a higher fluent, intelligent factor, right? Correct? But... Again, consider this a bit of magic for now, since we... You know, imagine if you're 15 and have already this kind of knowledge. Imagine. I mean, you should get some respect for it, correct? Again, consider this is a bit of magic for now. No, it's not magic. Okay, listen, okay. Should error in enumerations. We show an improvement version of operator that allows input via text. We're not going to do the quiz thingy. Because we want to finish this topic. So, how we ended up. Actually, the topic today was declaring a C-style array, and then I read it just to this line, and then yeah, the rest is story. And now we're already in 2 hours, kind of. I heard about the kernel 5 months ago, and this lad is 15. But there are some people, or some even parents, or whatever, and imagine if someone just starting with like 8 years starting to program, or 9 years. If you're 18, you're like just a 5-head. He's just 10 years ahead then. Not 10, but still. You never know. You never know. So, okay. So let's keep going with the topic. The array length of the C star array must be a constant expression. So I think a more precise question is, how many years you already programming Disco? The array length of C star array must be a constant expression. This is decent. I mean, just like std array, when declaring a C style array, the length of the array must be constant expression of type std size underscore t, though this is typically doesn't matter. Tip: some compilers may allow creating of arrays with no const expr length. Wir haben das schon gelesen, oder? Haben wir das schon gemacht? Yeah, we did this topic already. Where was it? This is where we ended up. Let's keep going here then. Scripting a C-style array. Just like with a std array, C-style arrays can be indexed using a subscript operator. Yeah. So that makes sense. Good. Unlike the standard library container classes, which use unsigned indices only, the index of the C-style array can be either a signed or an unsigned integer or an unscoped enumeration. This means that the C-style arrays are not subject to all of the sign conversion indexes issues that the standard library container classes have. Okay, we have this. Okay, then we have integer s2. Std 0. Okay, this to use a signed index. It's gonna work. Okay. This use. Okay, I got this. C-style arrays will accept signed and unsigned index or unscoped enumerations. But what is gonna happen if it's minus? Are we gonna get an error? Probably, right? TFC operator. I don't. You can, because you just can. Probably, I don't know. Oh, yeah, you're right, Lettermate. Oh, I really forgot about this topic. Aye. Oh, you're so right. How I could forget this. Implicit, explicit, yeah. 2 months ago, right? So does not do any bounds checking and passing in out of bounds index will result in undefined behavior. These are every except sign. Yeah. As an aside, when declaring an array, for example, integer array, angle brackets, right? 5. We use the of the angle operator is part of the declaration syntax, not an Invocation. Invocation? I don't know. I have to figure it out. Here we go.
Invocation.
Invocation of the subscriber operator. Subscript operator. Okay. Next word.
Aggregate.
Okay. Just like std arrays, C-style arrays are aggregate, which means they can be initialized using aggregate initialization. As a quick recap, aggregate initialization allows us to directly initialize the member of aggregate. To do this, we provide an initializer list, which is a brace enclosed list for comma-separated initialization values. Okay, sorry guys. Fibonacci. Oh, here we go. 6, and then we have this. This is copy list initializer using brace list. And then we have the prime. Prime 5, 2, 3, 5, 7, 11. List initialization using brace lists. Yeah, this is more safe. Okay, got it. Yeah. Yeah, got it. So each of these initialization forms initialize the array members in sequence starting with element 0. If you do not provide an initializer for a C-style array, the elements will be default initialized. In most cases, this will result in elements being left initialized, because we generally want our elements to be initialized. C-style arrays should be value initialized using an empty brace when defined with no initializer. Makes sense. Member default initialized in integer elements are left uninitialized. Member values initialized integer elements are zero initialized. Preferred. So we're not ending up with undefined behavior here, right? Probably if we're pointing to something, I don't know. I never find I have to use those arrays types. Std array for static size and std vector for dynamic is much better, safer. I mean, this type, I really like these types. This is the topic implicit and it disallows explicit conversions, right? Was it like that? So if more initializers are provided in an initializer list than the defined array lengths, the compiler will error. If fewer initializers are provided in an initializer list than the defined array length, the remaining elements without initializer are value initialized. So here we go. Compiler error too many initializers. Okay. That's too many. Wow. This is nice. One downside of using a C-style array is that the elements type must be explicitly specified. CTAD doesn't work because C-style arrays aren't class templates, and using auto to try to deduce the elements type of an array from the list of initializer doesn't work either. Either, I don't know. Auto square blah 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 blah. It's not gonna work, right? Because of... Yeah, okay. This is a little bit weird, but it is what it is. Compiler error can't use type deduction on C-style arrays. Yeah, it is what it is. Omitted lengths. There is supple redundancy in following array defined definition. See it. We not need the 5 because of the... No. Or is it the const? No. I think it's the const. It is the const, right? No, it's not the const. It is the const. Let's see. They are explicitly telling the compiler the array has length 5, and then const is fine. It's the size here because we not need it. Has length 5, and then we are also initializing it with 5 elements. When we initialize the C-style array with an initializer list, we can omit the length in the array definition and let the compiler deduce the length of the array from the number of initializers. The following array definition behaves identically. So we have, const in prime 5. So it's read-only prime 1, expletive defined to have length 5. Exactly, and then prime to deduce to compile to have length 5. Yeah. Let's go up here. But then we have not that one, right? I mean, you could use something like this to prevent that the array will be bigger, for example, for initialization. I don't know. I would probably use this here. The only works when the initializer explicitly provided for all array members. So integer bad arrow, the compiler will reduce this to be a 0 length array, which is disallowed. Yeah. Of course. Makes sense. When using an initializer list to initialize all elements of a C-style array, it's preferable to omit the length and let the compiler calculate the length of the array. That way, if initializers are added or removed, the length of the array will automatically adjust, and we are not at risk for mismatch between defined array lengths and number of initializer provided. Best practice: prefer omitting the length of a C-style array when explicitly initializing every array element with value. Oh, now everything is coming up, boys. Everything is coming up. Here we go. I thought it will be a small topic, but it seems not. Const and const expr C-style arrays. Just like std arrays, C-style arrays can be const or const expr. And what I learned so far, const expr is not always on compile time, right? It can, but it not have to. Just like other const variables, const arrays must be initialized and the values of the elements cannot be changed afterwards. Okay. Namespace, then we have program data, const expr integer square 5, then we have 1, 4, 9, 16, 25, an array of the const expr integer. Yeah. So, no, const expr needs to be known at compile time. This is correct. You're correct. But it still can run on runtime, if I'm correct. You know what I mean? It has to be on defined on compile time. But it will not... It could be that it's... I watched a YouTube video about this. Wait, where was it? Const... Maybe I'm mixing up stuff. So it's good that you mentioning that. Where was it? Let's watch this quick. Be right back. Okay. Lettermate, are you ready? Here we go.
Hello and welcome to C++ Weekly. I'm your host, Jason Turner. In this
This title triggered me so much that I want to watch it back then. It was really interesting.
episode, I need to clear up some misconceptions and misunderstandings about constexpr, and I think give you a best practice for how to move forward with your constexpr usage in the future.
Okay, enough cringe time. Widescreen,
This episode of C++ Weekly is sponsored by me. Be sure to check out the video description for important links about upcoming events, sponsoring the channel with Patreon, buying copies of my best practices and puzzler books, and how to contact me if you are interested in on-site
312 weeks.
training or remote code reviews. Now, just a quick important note before I continue. This episode is being recorded and aired at this particular moment because I need this information for background in the next episode that I will be recording shortly after this one. So you really should subscribe and make sure that you see the next episode to come up because I think it's a pretty good one. I hope it'll be a good one. Okay, so I have here constexpr probably doesn't do what you think it does. And I know when I do a title like this, it tends to be a little bit clickbait, makes people respond, oh, of course, I knew exactly what constexpr did this entire time. So I don't know what I'm going to actually title this episode just yet, but hopefully it'll be something creative. The misconceptions around constexpr go something like this. Let's go ahead and create a function. And
Okay, Letterman, what is your statement about constexpr? You said it is needs to be known at compile time. I think this is correct.
it's just going to be called getValue. It's going to be pretty trivial. We're just going to return 2 times the value passed into us. And then down here in main, I am going to use this value. So if I have this, and now I'm getting a error. Let's see, we want to do 6 times 2, that's going to be 12. We're going to return the value here. Now the question that we have is this value calculated at compile time? Now if we look here at the compiler explorer output, we're probably not going to be surprised to see that it returns 12. That's all this program is doing. The optimizer has done this work for us. So let's just go ahead and say, is this value calculated at compile time? For this version, maybe up to the optimizer. But there is a second question that we have to ask, and that is the value usable in constant expression?
1 second. So, okay, keep going.
This might sound a little meaningless without a little bit more context. So we're asking, is it usable in a constant expression? And the simplest way to check this is to do a static assert. We're going to static assert that value equals 12. And we're going to get a compile time error because this is a non-constant condition for static assertion. This is not usable in a constant expression. Now, if we make it const, and you've seen me cover this in previous videos, then it falls under other rules related to things that are called core constant expressions. This is constant initialized. It is available in a constexpr context. Let's comment this back out again. And now we still have this question of, is this value calculated at compile time? And the answer is still maybe. It's up to the optimizer whether or not this is calculated at compile time. Now, if I do a static assertion here, then yes, it is calculated at compile time. Because I required the value in this constant expression context, now the compiler was required to give me this value at compile time. So let's comment this back out again, and let's make this constexpr. And I'm still asking, is this value calculated at compile time? And interestingly, the answer is still maybe, because we haven't done anything to require the compiler to calculate this at compile time. Now, I will say, in my experience, GCC is very aggressive about calculating values at compile time. And it's outside the scope of this video to show where and how. LLVM, somewhere in between. And then MSVC is somewhat lazy about this. It's only going to calculate something at compile time if it must. Which now starts to bring us to the point of this video. So constexpr here, we have really no idea if this thing is going to be calculated at compile time. The only way to force compile time calculation is to do this static assertion down here. So let's go ahead and let's make a new function.
So, Lettermate, is this something new for you?
So let's look at this, theoretically relatively expensive thing to calculate here.
So you know this already, or what? That the calculation will be maybe not on compile time.
And we are going to go ahead and assign this to a local variable. And it would be helpful if the entire thing was not initialized to 0.
Or like it that he's doing the plus cut. I really like this.
Okay, so the compiler has optimized all this away. It is returning 2,637 for me, which sounds about right as 879 times 3. But it was not required to. So let's go ahead and take this back to O0. And we are in GCC. So we can see that the compiler has for us calculated. Let's look at this here. This sub 4000 from RSP. Now what the compiler has
you can't see it,
here,
damn it. Wait 1 second, I will deactivate my cam. So it's like the Leah stuff, right? What is...
That has created space for 4,000 bytes. That is 4K because we've got 1,000 integers. They are 4 bytes wide each, and it has created space for 4,000 bytes for us. And then it is going to copy this data in. See this repeat move SQ? It is copying the data from this compile time array into the local stack. And that brings us to the point of this video. Maybe this will be the name of the video. it is const expert values are stack values. Maybe that's what we need. Well, I've experimented a bit here and I have been unable to get an actual stack overflow to occur, which is a little disappointing, but it's also not really relevant here. I think that you've gotten the point that const expert values are stack values. They're not some magic thing that exists, you know, in static initialization in the compiler. They're not required to be calculated at compile time. In this particular case, any compiler here could go back to doing this thing at runtime instead of compile time. It is not required to. But I really want to drive home this point about this being a stack variable. Now, in real-world code, it's entirely possible for this to actually take a fairly significant amount of time to execute because it now has to copy this large blob of data onto the stack and possibly do some calculations there. So let's go ahead and illustrate this.
This is enough, but it's really interesting, isn't it? For me, that was new, right? But it's good to know. Okay, let's keep going. Const and const expert C-style arrays. Just like std arrays, C-style arrays can be const of const expert. Just like other const variables, const arrays must be initialized and the value of the elements cannot be changed afterwards. Include IOStream, namespace, program data, blah, 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 blah. And then we have an array of const expert integer. Okay, we have this. And then we have const int prime. 5 initialized with this thingy. 1, 2, 3, 4, 5. An array of const integer. And then why are we using it now like this? Before we had like, we should not use it. Okay, never mind. And then we have prime 0, 12, compile error, can't change const int. Yeah. Good. The size of the C-style array. In previous lesson, we used the size of operator to get the size of an object or type in bytes. Apply to a C-style array, size of returns the number of bytes used by the entire array, including IOStream. So int main const int prime, and then we initialize it with 1, 2, 3, 4, 5. The compiler will deduce prime to have length of 5, correct? Then we have std out size of prime, and then prints 20, assuming 4 bytes per integer. Assuming 4 bytes integer, the above program prints 20. The primary array contains 5 integer elements that are each like then 4 bytes each. So 5 multiplied by 4 equals 20 bytes. Note that there is no overhead here. An array object contains its element and nothing more. This was also kind of interesting. Getting the length of the C-style array. In C++17, we can use std size defined in the iterator header, which returns the array length as an unsigned integral value of type std size underscore t. In C++20, we can also use std scope operator as a size, which returns the array length as a signed integral value of large signed integral type, probably std ptr and whatever. So then we have iterators for std size and std s size. Then we have const int integer prime. The compiler will reduce the prime to have length of 5. And then this is the method C++17 provide us with the size prime. And why are we calling it s? Like the s size thing. Returns unsigned integral value. Signed. What is a signed integral? It's a signed integral. Okay. The plus minus. Okay. Yeah, but why we want to have it like this? I mean, it can't be minus, right? Why we want to have a signed integral there? I mean, am I mixing up again? Is it the other way around? Maybe. Wait. What is unsigned again? Always. Yeah, unsigned make more sense, right? Why you want to have... What is the case that you want to have the... Can someone maybe explain? Unsigned +1. What is decal type? So you have an unsigned integer +1. And then 1 is also like an integer. What is the type of adding an unsigned and a signed? Ooh, this is a good question. Oh, 03401 is there. Because of C's weird integral rules. I don't know. I don't know. I literally don't know. It's magic, lettermate. CO3F004, you know? It's unsigned, and that's surprising. Size keeps the type as signed. So if you have unsigned plus an signed one, you're getting an unsigned one? What? Yeah, sorry, lettermate. Sometimes I'm speaking just, but good for calling me out here. So why you want to have a signed integral value 5 then? Like, why you want to have then as size prime? Why you want to have a return signed integral? Why you need this even? Unsigned would make absolutely sense. You mean just for the scenario, if you're getting a unsigned one, number greater than size of prime should be, but it's not low. How C works. Okay. I mean size, okay. How it's working then? So it would be smaller than 0, is it not, or what? Maybe it's also language barrier thing now again. Let me check. Ah! So I asked ChatGPT, it's like if you want to try to divide an empty container by a not empty container, then you getting into some troubles, it seems. It's your example what you did before, right? And then you have also like a sizing problem. So if you have, for example, a container that is above the maximum size, then you need also the unsized thingy. Ultimately, it exists because the rules regarding unsigned numbers don't make much sense for the common case. Unsigned means a modulum number, but people generally interpret it as a natural number. What is a modulum number? I get it. Right, I think I get it. What is a modulo number? What is a modulo number? Letter mate? Now is your time to shine. I don't know what it is. It's a number that wraps. Yeah, danke. What wraps? I don't know what wraps means even, man. Ah. Infinite? So let me check.
Infinite wisdom.
Infinite. Okay. Ah, got it. Okay. That makes sense. Yeah, I got it. Thanks a lot, guys, for having me here. So keep going. Getting a length of a C-style array, C++14 or older. Prior to C++17, there was no standard library function to get the length of the C-style array. If you're using C++11 or C++14, you can use this function instead. We have our template. Template size char minus 10 smaller equals 0. Is this true? C-style? C-style, let me think. So from the logic, you would say, yeah, it's smaller, right? Oh, how is the char is defined? Is the char unsigned or signed then? Oh! So we would have an undefined behavior. This would be what you would expect, like, no, it's defined. So you would expect you know the char is 1 byte. So you would get 1 minus 10. So 9. 9 is not smaller than 0. So it's false, you would expect. But probably now, surprise, surprise, we got getting something different, right? Hey Edward, how you doing? Is an unsigned integer. Okay. So an unsigned integer, so it can be The result is not 9. No, I mean -9. Sorry. 9. It's 9. No, it's not -9. Wait. Sorry, guys. That's just bullshit. So, size char is 1. It's unsigned, right? And 10 is what? Wow, this question is not that easy. I would expect that 10 is an unsigned number. And then char would be, what you said, is also an unsigned number, right? Well, I'm confused. Now you know what the issue is. Yo, this is... So the result would be 9 or what? The result is not 9. What is the result then? Wait, size of size t which is unsigned. What is unsigned minus unsigned? Is still unsigned. Any unsigned smaller is false. What? It's just defined as like this. Wow. Imagine if you do something this in an exam in the first semester. That would be like a really, I would say, dirty move. Would it be? Imagine you doing something like this. It's just false. It's just false. Yeah, the question why it's false. Is it just defined this way? Any unsigned smaller 0 is false? No. Now I'm even more confused, boys. The LHS is a unit and unsigned integer cannot be negative. They are defined as modulo numbers. Okay. So, but how is why it's not breaking then? If you have then still the statement, I would expect at least that it's crashing. So it's justified any unsigned smaller 0 is false. Because it can't, it makes, okay, I'm getting it. Because it can't be smaller than 0. So if I have an unsigned number, it will be always bigger than 0. In C++, there is no under overflow of unit, unsigned integer. No, it's a defined behavior. It just doesn't match what you think it does. So if I have something like this, an unsigned number, can't be smaller than 0. Any normal person thinks of those are natural numbers, which is different. There is no natural numbers in C. Oh, interesting. But how I'm gonna do it then? I mean, still, why it's... I could have the case 1, right? I could have the case 1. Is it then still any unsigned number smaller than I'm right now super confused, boys. So if I have an integer a equal 1, so integers are signed numbers, correct? By definition, if I'm defining something, initialize an a with -1 or something. Okay. So I have to be aware of if I'm using unsigned number. So if I would have an unsigned number smaller than 6, it would be also false or what? 1 second. I'm ready for the answers. Let's see. Any normal person think yes. That is being evaluated at compile time only. Constable does. This. Oh, guys. Again, quick. Before we're doing the constant stuff again, one second. Does it mean CO3F001? Does it mean that if you're doing this kind of comparison with the unsigned number, it's always false? Yeah, even if you have the statement unsigned smaller than 6, you're still getting a false statement. There's no unsigned number small. Yeah, but if you change the statement, I mean, then it would work, right? Okay. I just, sometimes you have to ask, do you know why? Because we're living in the C++ environment, right? Sometimes we have magical stuff happening, right? You're expecting something, but it's completely the other way around. And then it's hitting you from the back. Man. Okay, keep going here. We have a template. I should work way more with templates. I'm gonna do off stream some stuff. So type MT blah blah blah. Okay, we have this one. Size T. Okay. Okay. Wow. Okay. What? This is juicy, man. Okay, with no except. Okay. For undefined behavior. Then we have const export. Then we have const t. Okay. What is n? Why we can do something like this? Okay, I'm just gonna read. This is juicy. Just look at a second template parameter. Okay. Got it. Thanks a lot, man. We have a second template parameter. Okay, then we have the array. Okay, this uses a function template that takes a C-style array by reference and then returns the non-type template parameter representing the array length. In much older code bases, you may see the length of C-style arrays determined by dividing the size of the entire array by the size of an array element. What kind of discussion do we have here? What do you mean? Need a strong word. It's only needed to be known at compile time for const export to have any effect. What kind of discussion we have? So here main okay. I did this also sometime. Yeah, size of array and then size of array. Mhm. Nee, das habe ich noch nie gemacht. Warum sollst du sowas machen? What the? What? Why you should do something like this? Okay, this prints the array has 8 elements. Remember that C sucks. Yeah. Sometimes you said also like C++ sucks, right? Okay, why? What is this? Hello? Imagine you have something like this in the exam. This is funny. I don't know. Is it size of array? So we're getting the size of the array, but why we should do something like this? I mean, is it not enough if you're just saying size of and then we're getting the array? Why we should divide it? There's no alternative offered unless you want to store that 8. Ah! You mean if you're doing it like that? Wait, but you could just print it out, right? Oh, ja. Ja, jetzt geht's hier um Grundlagenforschung. Let's go. Grundlagenforschung, here we go. Okay, what's gonna happen if I'm doing this? So we have 32 bits. Hä? Warum kriegen wir 32 Elemente? 4 Bits, 4 mal 8. Nee. Doch. Mit Integer Type, ja. Ja, das ist richtig. Dann haben wir das Size off und dann machen wir es halt okay, wow, okay. Und wenn wir das andersherum haben, dann kriegen wir halt die 32 Elemente. Ja, I did something like this and then we have size off and then array 0. And then, I did this. I remember. Aha. I remember. Where I wrote my CSV file parser, but I have a way better solution now than using this instead. So that's why I was yeah, you got it. Okay. How does this work? First, note that the size of the entire array is equal to array length multiplied by the size of an element, put more compactly. You know, the thing is sometimes if you're using C++ stuff and then you're using again C-style stuff, you're thinking, you're getting the size, and then you're not getting the size, you're getting like, you know what I mean? You have to ask yourself what kind of from what kind of objects or what element you're getting the size of, right? Array size. So how does this work? First, note that the size of the entire array. If you want to watch this video, I can send it to you over, right? There we have this const expert stuff. That's really interesting. I really like this series. I don't know how serious. I don't know how good Jason Turner really is, but maybe you can say it. But I think he is good. Sven, I have a serious question. What is your serious question? You want to just test me or? Come on. Bring it up. Where's your serious question? Oh, this is month ago, man. How and why did you? Oh, yeah. I mean, how and why did you learn VTabs before you know how to calculate how many elements were in the array? I know. The thing is, yeah, okay. I mean, I did this already, right? But sometimes you're just mixing up stuff. Should I know this already? For sure. Because I used it already, right? Was ist das, Feines? Was ist das? Ah, so, ist das noch gut? Bist du sicher? Ey, ich hab keinen Bock. Wirklich, Melina. Das ist schon ein paar Tage alt. Ja, du hast es probiert, aber nee. Schnucki, das ist zu risky. War das im Kühlschrank? Ja, Schnucki, das ist mir zu riskant. Hä? Ja, wann haben wir das gegessen? Mittwochabend. Nee. Ich esse später vielleicht. Nee, ich esse später vielleicht. Kannst von mir noch gerne was haben. Eat it now, coward. Ja, guys, exactly. So sorry, guys. It was like a private, private talk here. Schnucki, hörst du jetzt mal auf? We can lip read. Yeah, do it. So you have just created an AI, so you can. This probably someone did already an AI for lip reading. This serious question is kidding me though. But I mean, to be honest, yeah. Here, okay. We are close. Let's do it. Put more complexity, array size equal length multiplied with element size. Using algebra, how it is called in English?
Algebra.
Algebra. We can rearrange this equation. Length equal array size divided element size. We typically use size of array 0 for this element size. I used it so many times and I don't know why I just forgot it. Therefore, yeah, because I'm not practice it enough, right? Have to practice more. And actually, I'm using something else than this, but it makes even sense if you want to know in which kind of environment you are, if you want to check an integer, right? For the element size, therefore, length equals size of array, size divided by size of array 0. You may also occasionally see the written as size array divided by size. Oh, yeah. Can do it this also like that, yeah. This is also working. Yeah, okay. With just the same thing, okay. Interesting. Also on the topic of Jason Turner, he is knowledgeable about C++ language, but has never really programmed anything cool. I mean, you can focus on different things, right? You can master language, be really good in a language, just tested a lot of stuff. Or you're good in graphic programming, or you're good in embedded system programming, or you're good in, I don't know, web development, I don't know. Which does the same thing. However, as we will show you in the next lesson, this formula can fail quite easily. Okay. When pass a decayed array. Leaving the program unexpectedly broken. C++70 use std size. Yeah, that's the thing. I'm using since then just std size, and that's why I not use this anymore. And I forgot about the thingies here. And the length function template shown above will both cause compilation errors in the case, so they are safe to use. So this could be the next good topic, C-style array decay, right? This is something for off-stream. I am here. Welcome back. So, my girlfriend asked me if I'm finished for the day. What is your answer? Probably a yes, right? I mean, we're already 2 hours, 3 hours in. We should do this topic tomorrow. How many lines have you written yet? Today, you mean? You should not forget that I'm doing a lot of stuff like off-stream. Not a lot, but I'm doing some stuff. And I did a lot of quicksort stuff. Even off-stream, I tried to optimize my quicksort. Yeah, I was able to do it. Actually, I want to do more algorithm stuff. Actually, it's kind of fun to try to optimize them. So where's the next topic? Right, is this the next topic? It is, right? No. It's such a big topic here. Just gonna save it on my desktop. So I think I'm calling it for today. thanks a lot for helping me. And probably I'm tomorrow here again. And yeah, tomorrow, I think if I'm tomorrow here, sitting here in this chair, I'll be doing a little bit more programming. So if you have some C-style challenge for me, like not C-style array challenge, please let me know. Maybe I should try to program the quicksort in a C, like using the C-style array. The C array. C-style array. Is it, what is the name? Yeah, it's C-style named, right? So, I'm out. Thanks a lot for helping. See you tomorrow. Kick 7.